Evaluate the integral. Answer exactly. So we have the definite integral from 0 to 1 of dx over the square root of 1 minus x squared. And this is a very specific kind of integral. The thing about this is, first of all, it involves division. So we have some function in the denominator. And generally speaking, we don't have a quotient rule, so what we try and do then is rewrite the thing so that we can use a power rule. But that's not really going to help here because the denominator also involves a square root, and we don't really have a lot of means of integrating square roots in the first place. So you just need to remember that this specific type of integral, notice the function here, 1 minus x squared is similar to a unit circle, and your trig functions are based off of circles. So this is going to be the type of an arc trig function. And those are formulas that you just need to have memorized. So here are the formulas, and we'll work through deciding which one fits this situation best. So if you have the square root in the denominator of a constant minus a function squared, that is of the form ArcSine. So that's what we're going to use to integrate. And there's not a lot to this process once you recognize that. Here we just need to identify the constant a is equal to 1, and the function u is equal to x, because this is a squared minus u squared. Now the other thing that needs to happen is I need to have just du in the numerator. Well, du is going to be just dx, and that's exactly what I have in the numerator, so I'm good there. Now integrating this, what's going to happen is I will end up with the integral is going to be of the form ArcSine, and it's u over a, so u is just x, a is 1, so u over a will just be x, and then it gets evaluated from 0 to 1. So, like I said, once you recognize that form, it doesn't really involve a lot of actual work here. To finish this off, what I need to do then is the fundamental theorem of calculus and just say this is the arcsine of 1 minus the arcsine of 0. And perhaps you're not too versed on exactly how to do arcsines, but that's okay. Your calculator can certainly help. Now just remember that when you get the result of an arc trig function, you're going to get a angle measure. And that angle measure is not going to be entirely easy to recognize in radian form. So perhaps it makes more sense in this case to switch over to degree mode. So when I do arcsine, so second in sine, the sine to the negative 1 means arcsine of 1, it's 90 degrees. But do keep in mind when you actually give your answers, those answers need to be in radians. So make that conversion. So 90 degrees is pi over 2. So this is pi over 2, and then arcsine of 0. Well, that one you should probably know because the sine of 0 is just 0, so the arcsine of 0 is just 0. So this is pi over 2 minus 0, which is pi over 2.